Okay, everybody, this video is on properties of dilations. This will be a very quick video. A dilation changes the size of a figure without changing its shape. Some dilations are enlargements, which mean that they get bigger, similar to like when you go get your eyes dilated before having your eyes checked. It makes your pupils larger. So some dilations are enlargements and some dilations are reductions, which means that they get smaller. In a dilation, the ratios of the lengths of corresponding sides are equal. So that just means you're going to create a fraction where you're going to choose some sides and you're going to choose a side of the new image and you're going to put it over the pre-image. So the new image is going to be over your old image and you're going to choose a side and its corresponding side. So let's look at problem 1. We have line A prime, C prime, and I'm going to put that line in gold. So that would be this line at the top. If you count up the length, meaning from A prime to C prime, is 5. And you'll put that information over the corresponding line on the old image, which is line AC. I put it in green. When you count up that line length is 2. If you take that, it's an improper fraction, just divide the 2 into 5, you get 2.5. Remember, this goes back to when we began the year talking about finding our constant or our K. So think of it this way: whenever you have a dilation, it's being enlarged or reduced by a constant factor. And that's what we're looking for right now to see if this is a dilation, because if so, then each line is going to be increased or decreased by that same number. So if you look, you have another fraction, which is B prime, C prime. I am going to highlight that line in blue. So B prime, C prime, again, and I have it in blue. If you count the line length, is 5. Then I'm going to do line BC in red. When you count it up, is 2. Improper fraction, divide the denominator into the numerator, you get 2.5. So your constant is 2.5. And since these are equal, this is a dilation. A prime, B prime, C prime is an enlargement of ABC because the ratios of the corresponding length is greater than 1, and A prime, B prime, C prime is the same shape as ABC, but it's just larger. And really, that's dilation. So what I would like for you to do is to pause the video and go ahead and work problem number 2, and then begin it back to see if you have the same information that I have. Okay, so for problem number 2, I already gave you the ratio. You just needed to put in the corresponding line information. So line A prime, D prime, which I'm going to put in green. So A prime, D prime. That line was just 2. The corresponding line on the old image would be AD. I'm putting it in gold. That line length was 6, so we have 2 over 6. In its lowest form, it will be 1 over 3. And if you choose another line, so that we can make sure that we do have a dilation, so we have B prime, C prime, and B prime, C prime, I'm going to still put that line in green. It was 1, and its corresponding line BC, put it in gold. It was 3, already in its lowest form. We can see that we have a constant of 1 over 3, which means that it is the same factor that is decreasing by. So because these are equal, this is a dilation. In A prime, C prime, A prime, B prime, C prime, D prime is a reduction of ABCD because the ratios of the corresponding length is, in this case, less than 1. In A prime, B prime, C prime, D prime is the same shape as ABCD, it's just smaller. And really, that is dilation. If you have any questions, please let us know. Enjoy your day.